All right, welcome back. In the previous chapter, we wrote a program, a C program, a procedural program to solve the area of a rectangle. I'm sure you would have completed this particular exercise and come to this particular chapter. In case you have not completed the exercise, please pause the video here, go to the previous exercise, complete it, and then come here so that you'll get a better understanding. You'll get better understanding of the concepts that we discuss henceforth. So for all the exercises that we have in this course and all other courses, I want one help from you and one commitment. I want to ensure you look at the demo and do the exercises, because doing the exercises will reinforce the concept that we basically have discussed in the theory session. So I hope you're all with me and you understand the importance of doing the hands-on exercises. So in case you have not completed, please again stop the video, pause this, go back to the previous chapter, complete the exercise, and then come to this particular chapter video. All right, I assume that you people have completed the exercise. Thank you for that. And with that, we will look at the next chapter, which is about an overview of object-oriented programming. In this chapter, we will just have a brief overview of classes and objects, two very important concepts of object-oriented programming, and look at how do we solve the rectangle problem with an object-oriented approach. We saw how to write procedural program using C and solve the area of a rectangle problem. Now, let us have an overview of object-oriented programming. So what is an object-oriented program? It is basically a programming style which is based on various metaphors. So it resolves around the concept of objects in pretty much the same way, where we interact with each other, we know each other like friends, and various roles that we play. For example, in a bank we see manager, in a shop we see a shop owner, something like that. In a hospital we see a role, person playing a role called doctor, nurse, etc. So that's a basic concept where an object represents a real world entity or a business concept. The object has a data and methods to operate with that particular data. So it encapsulates the data. Unlike procedural programming, where data is available kind of in a global space, here the objects encapsulate the data. So that is one of the basic difference between procedural programming and object-oriented programming. And the data can represent a scalar entity or a structure in general, which represent a particular entity. Every entity has some data, some attributes, right? For example, if you take a human being, there are certain attributes to a human being, right? You have an employee, so there are certain attributes to that particular employee working in an organization. A student working or studying in a college, for example, has certain attributes, like a student has a name, a date of birth, which standard or which particular course this particular student is studying. So like that, there are various attributes which represent the structure, and there are methods associated with that particular entity as well, or in general functions. So in the object-oriented world, we don't call it as a function. It is basically a method which actually manipulates the data within that particular entity. So that's a basic concept. So it contains two important concepts. One is class and an object. So what is a class? So a class is nothing but a structure. So it's primarily a blueprint that defines a data structure and certain methods which operate on that particular data structure or modify the data in that data structure. So that's a basic concept. You can treat a class as a template, a software template which contains certain common properties of that particular entity. For example, we have an entity called car. So a class called car can be created. So whenever you take an example of a car, what are the attributes that would come into picture? So you have the make of the car, so which company it belongs to, and what is the model. what is the color, what is the engine capacity, whether it is a manual transmission or an automatic transmission. So like the transmission type could be a data associated with that particular car. So that is nothing but the concept of data which represents car. Similarly, there are various entities like your television. You take television. So television has a make, has a model, and television has different attributes, right? So it has the resolution, what it is supporting, and it also has the information about the power specification. So what is the amount of power it consumes, right? And what is the technology, like what it is basically being made of. Like if you have LED television, OLED, like that, there are different attributes which represents the structure or the template of the respective entity. And one important thing is that this structure is encapsulated as variables within that particular object, which is data, and we have behavior or methods where it operates on that particular data and creates different functionalities of that particular entity. For instance, car. What are the functionality of a car? Car can start. You can start a car, you can stop a car, and then you can drive a car, so the car is in the motion, or you can stop the car. So there are different behaviors that we can see in the car, right? So that's the basic concept of different behaviors which are encapsulated within an entity. Next, we have many objects of same kind. So when you have a class is basically a template or a concept, and using this template or a concept, we can create different objects. So there are different cars, different models, different makes. They all kind of belongs to a car. So that's why we say you have a car. Car is a concept, but the actual object could be something like I have a Hyundai car, Hyundai Verna, for example. So that's a basic concept. So they share same characteristics, and they are created from a blueprint, which is a class. So one class can be used and you can create multiple instances of that particular class, which are known as objects. So that is the second element associated with object-oriented programming, which is nothing but the real thing. Because car is a concept, but the actual car that you have, the real thing is like I have my car, which basically is a Kia Sonet, for example. So that is nothing but the real car, which has some real information, real elements associated with it. All right. So it basically in computing environment requires memory, because whenever we talk about data, I need some place to store that data, and where do we store? It is in memory. So an object is nothing but a group of attributes, and all these attributes require memory. So definitely an object created in an object-oriented program requires a block of memory. So that's very much important. And it's a software bundle which encapsulates the variables as well as the related functions or methods. In general, we call it as method. So whenever I say method, it is object-oriented behavior. We could say in the object-oriented programming environment, we use this term method. And then objects have a state. So what is the state? It is nothing but the value of its attributes at a particular time, right? So a student is still studying or in a particular place, or a car is stopped. So it is in static state, all right? So similarly, whenever you register on a particular website, right, you would see that the register is inactive initially. And once you sign up, after that you get a activation link, and once you click activate, then your account is activated. So account is inactive, account is active. So that is nothing but state of an object in general, if you consider account as an object. And then there are various behaviors, so which are nothing but set of operations. So one object or one class can have multiple behaviors. So we as human beings exhibit various behaviors, right? So that's a similar way we could basically see the real world entities and things that we see across. The same concept is being modeled in the object-oriented world. And how we exchange messages as human beings, even objects send messages to each other. So that is where you see a collaboration here where object 1 is sending and receiving messages from object 2, and object 1 also sends message to object 3, and in turn object 3 sends some messages to object 4. So like this we have a chain of messages which are basically being exchanged, and all the objects collaborate with each other and exchange data. So that is one important element that we basically need to understand, pretty much similar to human interaction, because even in human interaction we exchange a lot of data. All right, so there's a basic concept. Now let's get into the solution. So we have already solved the rectangle problem using a procedural language like C. So now let us try to solve the same problem using object-oriented technique. So here I will introduce to a Java programming environment, but still we have not covered the basics of Java, how the program works, etc. But don't worry, we will talk about that in the future videos. So let us try to understand how do we solve this particular problem. So in the object-oriented programming environment, the solution is encapsulated within a particular class or an object. So that's something we need to look at. So for this we define a custom data type or a new data type. Typically data, whenever we say there are different data types like number, string, right? So what is your phone number? Mobile number is like a number, right? But name is not a number, it contains alphabets, right? So that is where we have different data types coming into picture. Date of birth is represented by a date. So date is a type. Similarly, to represent my own structure like rectangle which has length and width, for example, I create a type called rectangle. So this is an example of a rectangle, and this is a representation which we generally use to communicate about our class design. It's called as UML. We'll talk about that in future courses, or unified modeling language. So this is a way in which you can represent a class as a diagram. Next, let us look at creating this particular class here. So we have the concept of a rectangle. So we create a class called rectangle, which has two properties or attributes, length and width. And then it basically has a constructor. So constructor is again a concept in object-oriented programming, which is about creating an instance. So this is the place where the data gets initialized. So don't worry too much about this particular program. We will understand how the Java programming work, how the object-oriented programs work in the future videos. So it becomes more easier to understand. So for now, we understand that we have to define a new type to solve a problem in an object-oriented way. Then we have a method called getArea, which encapsulates the solution. Remember, OOP encapsulates the solution. So we have the class which encapsulates the solution in itself. It's not like any function you can call. So instead it has the respective method. Then to solve the problem, we write another class, and then we have a main method. So just like how we have a main function in C programming, similarly in Java we have a main method, which is an entry point for a Java program, and we have an option where we can use this main method, and then we basically specify the length, width, something similar to the procedural language, but the only difference is that we instantiate or create an instance of the rectangle class, which is nothing but the instance. So we have R as a variable of type rectangle. So remember, length is of type integer. Now R is of type rectangle. So this is what I was talking about, creating a new type. Details will follow in future videos. Okay, just relax. Let us understand how this basically work, and we basically print out the same message, area of rectangle. This is the way in which we solve the program for computing area of a rectangle in an object-oriented fashion.